Um, this is what I have with a cube with my cube model, and it's simple enough. This is an 18 view inversion, 18 view and angle inversion that has each of those movers color coded red and yellow and brown or switched with their adjacent neighbor at the edge, and the faces are pushed through. Like this face would be pushed through to the back, this face would be pushed through to the back, and this face would be pushed through to the bottom, and same for the ones you don't see. The second step is to do the corners, and it has to have like a mirror type symmetry in it. Like this is the outer surface. Well, you can imagine the inside would have a square down here and the walls right here, and it does a square down here and the walls up here. So what you do is you take the color coded partial X pieces and you switch them over to the top over here, right here, and then you push them down, and they create the holodeck effect, the inverse holodeck. It's the same as invisibility on the outside. It's invisible on the inside, but it's in holodeck form. The same images that makes it look invisible when pressed inside and inversed becomes the holodeck scenery, and anything in that holodeck scenery when photographed would appear to float inside. I call that the floating photographic hologram, the volumetric interior. So you have a cloak, you have the holodeck, and any volumetric display of any object that was photographed through the photo cue would appear as a volumetric hologram, photographic in this case. And this is the resulting portal. Also, you need to morph the images at each of those angles to the photo cue, which is what this shows. Now, for these, this is what I've already discussed, and you can see the X pieces that form the corner angle views, the 8 vertices of the cube, and there's a face, straight on face. There's 6 faces to a cube. There's 12 edges to a cube, and there's 8 vertices to a cube. You can't do entirely the same thing with a polyhedron, the higher polyhedra. If you read the description to this video, you'll see that it needs to be each polygon needs to be treated like a cell. It has to have a depth that is equal to its edges. In order for that to happen, and so they don't intersect, there needs to be more of these polygons. This one couldn't be made invisible because it wouldn't have the depth for the walls to display the images at that angle. But if you added more polygons, it would increase the size of the polyhedra. Same thing with this. And or as the polygons become smaller, they would approximate pixels with the faces and the vertices will become one. That's the definition I give for a pixel. But the edges remain the same. There's 30 edges to this, 30 edges to that. Is at the edges that you take the pictures at, approximate pictures, regular 30 images around a central point, and you morph them through to their wherever their area of pixels are on here in an approximate way. And while the polygons approximate at the faces and the vertices as pixels, the polyhedra as a whole, polyhedron as a whole, approximates towards a sphere. And as you can see, any sort of polygon or pentagon or triangle or anything approximates pixels, just indistinguishable pixels. And but I've already thought of that with the 3 interfaces. The most important part, and if you read the description to this video, you'll see that the most important part is what I've done up here, the inversion, and on the polygons up to a sphere. You need an interface chambers, 3 interface chambers, and this is a little bit tore up or whatever, but this is a photographic portal polygon, and this is a full-fledged sphere, which has a high symmetry, but still it's an approximated polyhedra. And for an invisible suit, it's an irregular shape and doesn't have very much symmetry other than a human symmetry, and that needs to still have the fall where it may philosophy of the pixels in order to achieve the invisible effect on the outside and the holodeck effect inside the puppet interface. And if you read the description of this video, I think you'll understand better what I'm talking about. Thanks a lot.